So Rattle allows you to do this automatically, and I'm going to just go over the features in Rattle. I might not go through the software because it's very simple, but let's understand what the outputs are. So the data file I'm using, and you're used to it by now, is called Decision Tree EX. It's provided to you in your folder, your data folder. And this is the same data we used in the flower example just now, right? So it has got 5 inputs, which are categoric in nature, and we are trying to figure out whether it should be green or red. One more thing I would like you to notice is the tree we're going to get is not going to be the tree we just saw. And the reason is we are partitioning the data into 3 sets, and we are training it on 70%, and we are looking at the validation set of 15%. You could change it, and we're using a seed of 42. But if you change it, you won't get the same result. So remember, the difference in result is because my sampling is different, okay? So you execute, okay, and let me see what we did. You have to go to model, and in the model, you will have to execute, right? So when you went to model and you chose tree, and hit execute, it produces this output, okay? So N is 77 because only 75% of the data got into that, and it produces an output. So what does this output have? It has got various numbers. Let's quickly understand what they have. So first of all, it's got some numbers, and you see these numbers are not sequential because this is the best split in some way to remember. So first, there is a root. The first line is reading the root, 77 data points, right? And the majority category is green. So if you categorize this as green, you will be right, 79%. You'll be wrong, 20%, right? You will misclassify 16 of the data points. That's what it means. Then the next best split it is found is B. It's got B, B1, B, B2. You remember, B1 is completely green. So you can see that if you split it as green, and it's got a star against it because it stops there, that's a leaf node, which is saying I'm stopping. It's a pure node, and you are labeling it as green. There are 44 points on that. You can see that. There are 44 points on that. And there is no loss, which means the purity is perfect, okay? If you go B2, B1, B2, you will see that the majority there is green. So if you classify it as green, 51% will be right, 48% will be wrong. That's what it is saying out here. And 16 will be classified wrongly, and 17 will be classified rightly, right? That's all it means. The rest of it is just information as far as we are concerned. So once it runs the model, we can ask it to draw the tree. We can ask it to spit out the rule letters. If you do the evaluation part, it will give you the error. It says the root node has an error of 20%. Because 16 out of 77 is misclassified, and it gives you some data here, okay? Let's try to understand what this data means, okay? So these are the splits it's making, and as it makes the splits, the error is coming down, right? So what this means is, as I make the tree larger and larger, the relative error, so initially the error is 100%, and with the first split, it has reduced to 18% of what it was. And with the next level of the tree, your error is 0. So this is measuring relative to the original error you had. This needs some explanation. This is called a cross-validation error. What it's really doing, it's dividing data into pieces. It's fitting the tree in, say, 9 pieces and testing it on the 10th piece. So in this case, it is actually testing it, I think, on the validation set and splitting out the error. So this is the actual cross-validation error it is splitting out. There is a randomness to it because every time it does this cross-validation, right, you will get a different error. So you can find the average error on the validation set and you can find its standard deviation. If you notice, the cross-validation error in this case is also reducing the same way as the relative error, which is not true. So what we really are going to look at is the cross-validation error. What are the rules? So you can ask Rattle to, you click on it after you run the model and you can look at the rules and it'll print out all the rules, okay? These rules are different from the ones you got earlier, but look at the rule 1. It says, if B is B2, A is A2, E is E2, then it's red. And the probability is 1, it is red. Another rule says, if B is B2, A is A2, E is E1, C is C2, it's red. If so on. So if B is B1, which we know, it's green. And we know how many points it covers and what's the probability of misclassification, right? So let us look at the tree. So this is just your tree. Slightly different, but it also draws a fairly neat tree out here. It corresponds to executing the command draw out there. And you can see, so if you answer yes, you go to the left. If you answer no, you go to the right. That's a convention. So if B equal to B1, yes, you go this way and you get green. If you go no, you go to the right. And then you ask, right, is A equal to A1? Yes. A is equal to A1? No. And that's all the way the tree is drawn.